All right, let's look on at question 6. So this question is a substitution reaction of methane by chlorine. So just want to point out to you that the chlorine actually substitute one of the hydrogen atom into the methane. All right, this reaction is exothermic. First part they ask, in terms of bond breaking, bond forming, explain why the reaction is exothermic. Okay, bond breaking requires energy, right? Requires energy. Bond forming releases energy. Okay, so the fact that they told us overall, right, is going to give out energy, which means to tell us that the bonds that are formed actually give out more energy than the energy required to break the bonds in the original reactants, right? So that's basically about it. Okay, that is why it is exothermic. They said chloromethane, right, the substituted product, undergoes a similar reaction. So basically, what we want to do is we want to use a chlorine atom, one of the chlorine atom in the chlorine molecule, to substitute out a hydrogen again, right? So just repeat the whole process again, and then that will be your answer. Remember, displayed formula, right? Actually, by right, all the organic compound needs to show all the bonds involved. Okay, so Cl2 HCl is non-organic, so we didn't have to show the displayed formula. What's the value for enthalpy change of reaction between chloromethane and chlorine? So basically, right, if you look at the reaction itself, we are breaking one CH bond, H bond, we are breaking ClCl, and then we are forming ECl and a HCl, which is the same as the very first reaction. That is the same thing that we are doing. Breaking CH, breaking ClCl, and also forming CCl, and forming HCl. Okay, so basically the same uh, four bonds that we are referring to. So the delta H should be the same, right? The same bonds that are broken, the same two bonds that are formed. Okay, so lastly, they want you to draw the energy profile diagram. Okay, so since it's exothermic, right, we're going to start off with the energy level here, end off lower. Okay, so we're going to put in the reactants and also the products, right? And then this part here is you go up and then you come down, right? This part we'll label as the activation energy, and then from here the reactant level all the way to the product level is your delta H. Okay, so that's all you need to label in the graph. The axis you label it as energy for the y-axis, and also progress of reaction in the x-axis.